Hi everyone, I'm Rafal Korytkowski from OpenMRS. Today we are exploring how OpenMRS can be deployed on Kubernetes, one of the most scalable, resilient, and cloud-compatible ways to run your OpenMRS instance. The best way to start is by going to wiki.openmrs.org and searching for Kubernetes. The page describes in detail what we are going to cover to some extent today. Kubernetes is an open source container orchestration platform supported by major cloud providers like AWS, Azure, Google Cloud, but it can also run on-premise. We chose Kubernetes for its high availability, replication, optimized resource usage, log aggregation, monitoring, automated deployments, seamless upgrades, and excellent cloud compatibility. This makes it likely the most robust and failure-resistant deployment method for OpenMRS to date. To deploy OpenMRS on Kubernetes, we provide cloud-agnostic Helm charts. These charts set up the OpenMRS application and its backend components by database, search index, and file storage. You can even swap out the components for vendor-hosted alternatives if needed. Another thing that Kubernetes can help us with is multi-tenancy. A single Kubernetes cluster can host multiple OpenMRS instances, one container for backend and frontend per tenant, while potentially sharing DB engine, search, services, or file storage engine to save on hardware resources. Tenants do not share any data this way, but they can be managed from one place. Let's have a look at the architecture. Depending on your scale and requirements, the architecture supports single-tenant setups, ideal for small or large deployments. For smaller deployments, you can opt for MariaDB replication instead of MariaDB Galera cluster, and disable extras like Elasticsearch and MinIO to reduce resource usage. For larger deployments, you can run all the backend services and have them all replicated, which allows for horizontal scaling and guarantees high availability. The cool thing is that you can have the whole cluster set up within minutes with a single command, regardless if it is a small or large deployment. In multi-tenant setups, we include separate backend and frontend per tenant with shared database engine, search indexes, and file storage services. This scales horizontally and efficiently. If you want your tenants to exchange data, you need to build integrations. If you are interested, please reach out and we can work on that together as well. When it comes to requirements for a minimal setup, it's just 2 VMs with the spec which is listed here. In the minimal setup, you'll be able to run OpenMRS backend and frontend without replication, database, and database read-only replica. For recommended setup, we require 4 VMs with comparable resources, and this will allow you to run all the backend services and have them all replicated. I'm actually able to run the full cluster with all features enabled on my local machine with only 16 gigabytes of RAM, and as you will see, it's quite responsive. Of course, since it's running on a single machine and not 4 VMs, I'm not getting the benefit of hardware failure resistance with a single point of failure. Let's go through the features. So we have Helm charts and Terraform scripts for automated deployments. We have a proof of concept for AWS AKS Kubernetes cluster. In our Helm chart, you can enable MariaDB with replication with one primary read-write node and multiple read replicas, with load balancing between read replicas and automated failover and recovery handling for read replicas. Alternatively, you can choose to run MariaDB Galera cluster, which can have multiple read-write nodes and load balancing between all of them, as well as automated failover and recovery handling. When it comes to search, you can either choose to run embedded Lucene, as most OpenMRS implementations do these days, or switch to Elasticsearch cluster with at least 3 nodes, load balancing between all nodes, and automated failover and recovery handling. If you choose to run multiple replicas of OpenMRS backend, you will need to enable InfiniSpan clustered cache with replication and invalidation between nodes. And we also have health checks and automated restarts in case of failures. We have HTTP sticky sessions load balancing and rolling updates for OpenMRS backend and frontend services. Please note that deploying multiple replicas of OpenMRS backend is still experimental. And even though we made it work for OpenMRS Platform 2.8.1, not all modules have been updated and tested to work in such scenarios. So it needs to be used with caution. All right. I think we can move on to a demo. So we provide a deployment guide which goes through on-premise or cloud deployments within some extra Terraform scripts for Amazon AWS. But the easiest way to try it out is deploying to a local kind cluster. Kind provides a way to run Kubernetes cluster in Docker containers. And on the Kubernetes page, you can find the instructions you need to run to set up a kind, and also configure it with ingress and storage class. And once you do that, you will be able to access Kubernetes dashboard and deploy OpenMRS using Helm chart. And this is what I've done in here. And in order to deploy Helm chart, you can just use the default command with no extra values. But if you plan to deploy in production, you really need to specify all the parameters and values, especially usernames and passwords. And the way to do it is by creating a very basic configuration file. You can find an example of this file in OpenMRS country cluster repo or on the Kubernetes wiki page. The main things to configure are the default storage class and default ingress class. But also you can enable and disable different services. So for example, in this configuration, I am choosing to run OpenMRS reference application tree with a nightly core 2.8 image version, and I'm enabling 2 replicas for OpenMRS backend. I'm also enabling InfiniSpan cluster cache, I will be using a Galera cluster with 3 nodes and providing some default passwords and credentials to configure the database. And I'm disabling the MariaDB database engine with replication, since I'm using the Galera. And also I'm enabling Elasticsearch instead of the inbuilt Wilson index with 3 nodes. I'm also enabling MinIO, which is a service that allows OpenMRS application to store files in distributed storage. MinIO is a file storage service that is compatible with S3, and we have in OpenMRS 2.8 we provide S3 connector, so it's an ideal companion for the S3 as it can work on premise. And also I'm deploying OpenMRS frontend with OpenMRS reference application tree image and the same tag. So having this config file, I'm able to execute the Helm upgrade install command, and I will be using the OpenMRS namespace with values from the file, and I will call it OpenMRS. This pulls the OpenMRS Helm chart from the repository version 1.0.0 and also runs against my Kubernetes cluster. After a while, I should see a message that Helm has completed the setup and all Kubernetes resources have been created. It doesn't mean that the services are all up and running, but you can check the status by executing this command and seeing if they are running and or still starting up. Since I ran this command a while ago, it's already done, and it on my machine it takes from 10 to 20 minutes to complete the setup for the first time. In order to access the service, we have ingress configured, but I need to do port forwarding from my host machine to the ingress controller, and this Helm chart also provides you the exact command that you need to run in order to do that. In production environments, you wouldn't do that. You would have a load balancer configured in front of your Kubernetes, but for the purpose of this demonstration, I just use the simple forwarding, and now I should be able to access my OpenMRS running in Kubernetes cluster. And let's just quickly verify that everything is working. And what I want to show you is that how easy it is to do, for example, upgrades. And as I said, we have rolling updates in Kubernetes, which basically means that we can do zero downtime updates, And what I'm doing here is I'm changing to a newer version of the application, and I will be deploying that with the very same Helm upgrade command, and I will just run it. And as you can see, I was logged out by the application, and this basically means that my session, HTTP session, was running against one of the pods that is being upgraded, and I didn't see any issue as a user other than being redirected to a working pod which is running the old version of the application. But I can see in Kubernetes dashboard that there's another pod that is being initialized and upgraded to a newer version. And while this is happening, I am still able to access the service to do searches, and I'm not seeing any issues with the application. And what I actually see right now is that the frontend has also been updated in the background, and the color has changed. The nice thing here is that when the new version starts and there is some issue with the new version that it cannot properly start, the upgrade will be on hold, and I can go back to the upgrade process and roll back to the old version, correct the issue, and do the rollout again. And Kubernetes guarantees that there is always at least one pod that is healthy, that can serve requests, and only once the new pod is started and ready to serve requests, as we can see right now. So we have a new version that is already running. There is an upgrade applied to the other pod, and when I go back to the application, I see again that I was logged out, and this is basically the behavior of the service when you have HTTP sticky sessions. In the future updates, we may enable HTTP distributed sessions, so even during upgrades, users won't be logged out from the service and will be able to continue to work, as their session will be moved between different instances automatically. All right, so this is still being upgraded, and I can check the status. The pod is being initialized. Yeah, and what I would like to show you next is how easy it is to scale your application. So right now we are running OpenMRS Elasticsearch with 3 nodes. Basically, whenever I do a search in the application, concept search or patient search, the requests are load balanced between 3 Elasticsearch nodes. And when I, for example, start to see that the search slows down and the load is too big to be handled by these 3 nodes, I can go ahead and scale up, increase the number of replicas And I can do it via Kubernetes dashboard or Kube command line tool, but also using Helm charts. And after a while, I should see that a new pod is being created, and it will be automatically added to the cluster. And moreover, OpenMRS backend is configured to automatically discover new nodes, and after a while these new nodes should be included in load balancing, and requests should also go to this new node. The same works for OpenMRS Galera cluster. So we have Galera cluster with 3 read-write nodes, and I can go ahead and scale up. And after a while, I should also see that a new node is being created and added to the cluster. If it's a larger database, it takes longer to create a new node of a database, because the data needs to be replicated to the new node. And also in case of database, OpenMRS backend is not able to include the new node in the load balancing automatically. What needs to happen is OpenMRS pod needs to be restarted. This can be the need for the restart can be eliminated with a database proxy in front of the Galera cluster. We haven't yet added that, but it can be included at some point. Right now it's just that when OpenMRS backend starts up, it executes resolve MariaDB hosts container, and which basically discovers all the running hosts for Galera cluster and builds the connection URL, which is then persisted and used by the OpenMRS backend container. So let's maybe test some failover handling. So in order to test the failure, let me just try to log in again. And what I'm going to do is maybe start with killing one of his instances. So let's actually see the logs. So and the logs for OpenMRS backend 0 pod, I'm not seeing any requests. Whereas where I go to OpenMRS backend 1 and I open the logs, just see if anything appears. This is empty. I'm trying to determine which backend is serving my requests. I don't see any evidence in logs on neither, which is curious. Maybe it's not configured to log the requests. So I will just kill one of the pods and see what happens. So with load balancing in front, I should, as a user, I shouldn't see any issue with the service. Maybe just losing an HTTP session and being logged out from the service if I was on the pod that was destroyed, was not working. So let me see. So this pod is now restarted. The thing with Kubernetes is that when a pod is destroyed, it's automatically being recreated by Kubernetes as soon as it's possible. And as you can see, I was actually logged out, so my HTTP session was on this very pod that I killed, but I can still use the service, and I'm just being redirected to the one working pod of OpenMRS backend, which means the OpenMRS backend one. And the same applies to things like search engine. So if it happens that one of the Elasticsearch pods goes down, I can see that it was down and it's being terminated, and after a while, as soon as possible, Kubernetes should automatically recreate the pod, which has already happened. But still, when I do any searches or I should still not see as a user any issues with the service, because there are still 3 healthy nodes that can serve my requests. And similarly, when you do this for the database engine, I can just go ahead and kill one of the nodes. And this is also when it comes to database transactions. So if there was a transaction running on this node that is being terminated and it cannot be completed, it will be automatically replayed on any other working node. So in most cases, even if the user was during a transaction that was running against a node that is now killed, the transaction should complete successfully, because in the background it should be just replayed. All right, my token just expired for Kubernetes dashboard, so let me just try to recreate it and log in. Yeah, and I can see that the node that was down for the Galera is up again. The Elasticsearch is again running with 4 nodes. And yeah, so this is basically it. OpenMRS and Kubernetes, quick deploy, scalable, multi-tenant production setup. You can dive in, experiment, and I'd love to hear your feedback and how it works for you. Let me just go through what we are planning to work on next. And this is all documented in future work. So you might have noticed on the architecture diagram that there was a Grafana where all the logs should go, and we still don't have it in Kubernetes. So we want to add Grafana, which basically lets you to gather logs from different components of your application, from backend service, from integrations, set up alarms when anything goes bad, so you are notified, and view some metrics, how your hardware resources are being utilized, and if you need to scale up or down. We also plan to add automated backups for MariaDB with replication, or for MariaDB Galera cluster. Maintenance pages for planned upgrades. So even though in most cases you can roll out updates without any disruption to the service, there are cases when you have to, for example, apply schema changes that are not possible to apply in a way when you have an old version of the application still running, because it expects a different schema than the new version of the application. In such cases, you just have to roll out a maintenance page and notify users, or there are also other more complicated options, but for now we just do maintenance pages. We want to provide some status pages for users where they can see if the system is healthy or not, or if it's an issue with their connectivity. We plan to add multi-tenant support for shared storage clusters, so make it even easier to deploy multiple instances of OpenMRS backend and frontend with shared backend services. Something that I already mentioned is support for distributed HTTP sessions. So having the session being replicated to all the nodes in the cluster, so that when one node fails, the user is not logged out from the application, but continues to work on a different node. Auto scaling for services. It's actually possible to set up in Kubernetes triggers that can automatically increase number of replicas or decrease number of replicas based on the resource usage. And farther down the road, we will be working on AIP tools for integrating services, and maybe even sharing data between tenants, and also ETL services for doing data analytics. So there's still a lot of possibilities and things we can do, and we welcome contributions. So please reach out to me, or via talk, or by going to issues.openmrs.org and searching for support for horizontal scaling epic, where you can just see what we are working on right now, and also comment and basically share your ideas and how we can improve. All the code is stored on GitHub. It's under OpenMRS organization, and you can just search for cluster. It's OpenMRS country cluster repository, where we welcome pull requests, where you can find development documentation, how to set up a local cluster, how to build the Helm chart, how to run it directly from code. All right, that's pretty much it. Thank you very much, and happy deploying. See you guys.